Hi, everyone. Thank you for joining my talk titled The Risks of Open Source in the Software Supply Chain. I'm Crowther, Head of Solution Engineering at Snyk APJ. As open source adoption significantly increases and becomes the foundation of any modern application development, there are significant security risks and concerns that need to be addressed as more and more attacks are happening throughout the software supply chain. In this session, you will see how developers themselves are being used as a vehicle for malware distribution, unknowingly, of course, and how much we depend on open source maintainers to timely fix security issues and vulnerabilities, and how developers are taking more and more ownership across the whole software supply chain. Today, I would like to share with you some real-world examples of how developers play a fundamental role in some recent security incidents, why you should care about software supply chain security, and then leave you to think about who you should trust. Let's first have a look at a survey spearheaded by Snyk called the State of Cloud Native Application Security, or CNAS for short. It shows how developers are becoming increasingly more important in securing the software supply chain, and how DevSecOps, along with cloud native technologies, is helping organizations shift left their security concerns in the software development lifecycle. From the survey, the perception of ownership had interesting results. 37% of developers believe that they were responsible for securing the whole software development lifecycle, which was 3 times more than their security counterparts. Traditionally siloed organizations, the ownership of security squarely fits with the security team. But security teams are adjusting to this shift in responsibilities as the companies transition to cloud-native technologies. Developers are also increasingly aware of their new responsibilities that they have. This was all sort of pointed out in the report. So there is a new risk profile associated with modern software supply chain. This is because the way that developers build applications has fundamentally changed. It has moved away from largely constructing custom code to assembling open source libraries with their business logic. And increasingly, it's developers, not operators, are the ones who are responsible for the different layers of the stack, such as the proprietary code, open source library inclusions, the container infrastructure, and any of the deployment configuration scripts or infrastructure as code. We have seen from talking to customers that roughly about 10 to 20% of a typical application is custom or proprietary code, which is the business logic that makes the business unique or the application unique. Conversely, up to 80 to 90%, sometimes even more, is open source code. And we know that 78% of all vulnerabilities are inherent in the indirect dependencies that open source libraries bring in. That's quite a lot. Most modern applications will use containers, and there's also vulnerabilities that exist in hundreds of Linux packages that get downloaded as part of the container construction. And then finally, your deployment scripts or infrastructure as code has inherent vulnerabilities in it too. And it's said to be the #1 cloud vulnerability because it's quite easy to have human error or misconfigurations, such as leaving network ports open, running as sort of root or privileged users when you shouldn't be, exposing files, etc., over the cloud. So the point here really is to show that only the tip of the iceberg is the custom code that developers write. You need to think about all the other layers in the stack to securing the whole software supply chain. So let's put this into perspective. So we know 80% of application code is open source across all different types of applications and industries, doesn't matter. Vulnerabilities in open source packages have increased in the last 3 years by 2.5 times. And as we pointed out, that 78% of all vulnerabilities are found in those indirect or transitive dependencies, i.e. not the code the developers write. So let's take a simple example. So here we have a simple to-do application, a Java application, which has 3 files and 80 lines of code. Very simple application, but functional nonetheless. It has 7 direct open source dependencies. You may wonder, how many indirect dependencies do you think would be brought in this example? Well, 59 indirect dependencies. Doesn't seem like a lot, but the next number may surprise you. How many lines of code do you think those direct and indirect open source dependencies actually end up running in the application when you deploy it? Approximately 713,000, almost 250,000 lines of code is assembled as part of this simple application, which only had 3 files and 80 line of code to start with. So in this example, just about 99% of our application code was written by someone else, where we don't really know what the code does or where it came from. So the problem really is that organizations need to find and fix vulnerabilities in applications, but they don't even know that they brought in these dependencies in the first place. And it's often why these companies leave themselves exposed. To illustrate this point about indirect dependencies, let's look at the State of Open Source Security Report from 2020. It pointed out that a key risk factor in open source utilization is maintaining an accurate and up-to-date bill of materials. Organizations are challenged to understand what open source code exists in their applications due to all the indirect dependencies that are brought in from other libraries. In the survey, participants were asked about their ability to track open source software. As it turns out, 72% of organizations aren't closely tracking the indirect open source dependencies. And remember from before, 78% of all vulnerabilities are in the indirect transient dependencies. So this number is staggering. 33% are tracking direct, but not the transient dependencies, and 39% have no real idea what they're running in their applications. Because lots of companies aren't really tracking their indirect open source dependencies, developers have been targeted as a vehicle to distribute malware and backdoors for a long time now. Let's explore some recent events to illustrate this point. A Snyk-led security research in the iOS mobile applications ecosystem identified malware in the Integral Ad SDK, which is a mobile advertising SDK from a Chinese ad company. The Integral Mobile SDK is used for advertising attribution for mobile apps and was downloaded more than 1.2 billion times a month. And it was integrated into thousands of applications. These downloads are all of us, you and me, and everyone who use the most popular mobile applications directly downloaded from the Apple App Store, in fact. What Snyk found interesting is that the SDK had a proprietary obfuscated piece of code, which hooked into sensitive and careful system APIs on the mobile device, which it shouldn't commonly be used. This alerted suspicious behavior. And so what exactly did this SourMint SDK do? It intercepted all HTTP requests, and Snyk found that the SDK installs a backdoor used as a command and control instance, so effectively it can be controlled remotely. And to avoid detection, the SDK detects debuggers and jailbroken devices to go into stealth mode, so to become undetected. Another example is in 2018, the JavaScript ecosystem witnessed its first high-impact spearheaded surgical attack, targeting maintainers and developers working in open source and themselves being used as an attack vehicle to distribute malicious JavaScript code. It was designed to decrypt itself and run in a specific environment, targeting developers of a cryptocurrency wallet application and stealing Bitcoins. This was the well-known event stream incident. So a bit of history, I guess, about the event stream. It existed on the NPM JavaScript registry since 2011, so been around for a while. Hadn't received any new releases in over 2 years, but gained millions of downloads per week. Out of the blue, a person shows up on the GitHub repository, opening an issue and wanting to help, as is customary in open source. And to further contribute code with several pull requests where they added a dependency in the event stream's own package dependency tree with a supposedly genuine intent to improve the code base for event stream. A few weeks later, they add a code payload inside this dependency, which injects malware into the Bitcoin wallet application called CoPay. This had gone unnoticed for 3 months, resulting in 2 versions of the app being released that included the malware and lots of Bitcoins being stolen from consumers. So how much thought are we giving to the security of our own development infrastructure, resources like your cloud instances, build or CI/CD systems, and developer tooling? In 2021, a researcher broke into Microsoft's Visual Studio Code GitHub repository, essentially providing them with the capabilities of making code modifications to the popular and well-loved Visual Studio Code IDE that millions of developers use. It was due to a command injection flaw that was made possible as a valid attack vector because of a flawed regular expression. Simply by opening a new pull request, the researcher was now able to execute code in the VS Code CI scripts without requiring any sort of authentication or authorization. This led to the remote reverse shells on the CI servers, and from there, the ability to push and write access to the repository source code. Fortunately, the researcher responsible reported the flaw to Microsoft before advanced threat actors could exploit it. How much do we know about the current state of open source security and what it entails? In an effort to explore the security awareness of the Python and JavaScript open source communities, a group of researchers investigated how maintainers work in the open source community with regards to their ability to mitigate security vulnerabilities. One of the research questions was, how quickly do open source maintainers mitigate a newly published security vulnerability? The research found that it takes 100 days on average for both JavaScript and Python maintainers to mitigate a public vulnerability. You should ask yourself, is this fast enough for you as a consumer and user of the library? Can we really deny being part of an open source ecosystem as consumers, contributors, or maybe even as maintainers? We all play some part in a world where 90% of our application code is made up by open source components. What kind of malicious activities and assets can we track back to the open source ecosystems? Time after time, we find more and more malicious packages hitting the NPM JavaScript ecosystem. Hackers can plant these packages in the nested dependency tree, and your chance of finding them are basically zero. Malicious packages aren't just a thing in the the JavaScript open source ecosystem. Although I keep mentioning it because it's the largest of the open source language ecosystem and hence probably has the most vulnerabilities and pressed, etc. But to illustrate other language ecosystems, in March 2021, more than 3,000 malicious packages were published on the Python registry itself as well, the PyPy registry. To further illustrate how attackers can harness open source to their advantage, Alex Burson published his research in February 2021 about how he exploited design flaws in package managers, registries, and human error to infiltrate corporations such as Apple, Microsoft, PayPal, and Shopify. I found this article fascinating. You can find it by Googling his name, Alex Burson, and he was able to override internal package names that those companies were using with his external malicious code and collect information about the company. Now, Alex is an ethical hacker and was not looking to exploit these companies. Instead, he was looking to cash in on the bug bounties these companies offered. He collected more than $100,000 for his efforts when he reported these issues to the said companies. Now, I would like to leave you with the following questions to ponder upon. Are we going to have less or more software in the future? Are we going to use less or more open source software? And who do you trust? So, in summary, you're going to need a platform like Snyk that is keeping you secure across the whole software supply chain and your SDLC, and scans not only your proprietary code, but the open source packages that get utilized, which we saw is about 80 to 90% of the application. And when these applications get deployed into containers, you need to scan those too because of the Linux open source libraries that get imported. And finally, make sure that your configuration scripts that you use to build infrastructure has no known vulnerabilities or misconfiguration. All of this should be wrapped by platform features that give you governance and license compliance or usage across the stack. Also give you access to world-class security intelligence knowledge database to keep up to date with the latest sort of zero-day vulnerabilities. And above all, provide a great developer experience so that you can develop fast, but also stay secure. Thank you for joining my talk. Hope you enjoyed it. And you can follow me on Twitter @LozCrowther. Cheers. Thank you very much.